Hi, Sevda. Thanks for your email. I'm going to try to help you with your conversions. I know these seem really confusing. It takes a little bit of practice to get used to them. So, with the example that you're given, one of the important things to notice is that you're going from a larger measurement to a smaller unit of measurement. When it's the other way around, like it is on the part B here, you're going from a smaller to a larger. And so everything's going to flip, okay? So when you start this one, you start with nanograms. Oh, that doesn't show up very well. Let's make that red. Nanograms, okay? And when you're doing this, then what's going to happen is all of the bigger numbers are going to be on the bottom part of the fraction because you're going from a smaller to a bigger unit of measurement. So you're dividing each time because it takes so much more of the small ones to make a big one. So with nanograms, for instance, the first thing that we would write is we would go from nanograms up to milligrams. And I think there's 100,000 milligrams in a it takes 100,000 nanograms to make 1 milligram. So we would write it like that. And the goal is that you're always going to want to be able to cross out the units like that, one on the top, one on the bottom, okay? So now we're at milligrams, and what we want to do is move up to grams. And so again, we start with the bigger measurement on the top, and we say 1 gram would be 1,000 milligrams. And that way those milligrams are going to cross out. So far we've gone to, like the unit that we're working in now is grams, because everything else has been canceled out. And then we have to get up to kilograms, so 1 kilogram would require 1,000 grams. And again, the grams will cross out with that grams. And so now we've gone from nanograms where we started to kilograms at the end, okay? And so you've got to also multiply this number by this number by this number. And so we have a number with 12 zeros, so you can write out the 12 zeros, or you can write it as 1 times 10 to the 12. 1 times 10 to the negative 12, or 0.0000000, and keep going all the way out to 12 decimal places before you get to the 1, okay? So it would take a lot of nanograms to make 1 kilogram, and so if you only have 1 nanogram, that's why it's such a small amount of kilograms that we have. So the scientific notation of 10 to the minus 12, that's telling you that we're taking the number 1 and we're dividing it by 10 12 times. So we're going 1 divided by 10, divided by 10, divided by 10. And you keep doing that 12 times, you're going to get a really tiny number. Okay? So if we're looking at B, and I'll make you a second video for part 5, and I'll do one of those for you to get you started. The first thing that you need to know is the relationship between atoms and moles. And so 1 mole, and I guess they're expecting you to memorize this, or did they give you all of the conversions? I'm not sure, because I'm not really that familiar with your course. But 1 mole is equal to 6.02 times 10 to the 23. That's Avogadro's number. Atoms. Okay. So how we convert is if we start with atoms and we're going to moles, we're going to do it just like at the top there. And so there's more moles, or moles are a bigger unit of measurement than atoms. So moles are kind of like your kilograms, and atoms are like your milligrams. Like there's, one's much bigger than the other in terms of a unit of measurement. So if we are going from a small to a big, then we're going to be doing 1 over the conversion factor, just like we did in part B above. And so you're going to do that. And so you will end up with, this is 1 mole, and this is atoms. and you'll end up with atoms crossing out atoms, and you end up with your answer in moles, okay? And you would have to, on your calculator, take 1 and divide it by 6.02 times 10 to the 23. So I'm going to stop there because that's question 4. And then I'm going to do a separate video to get you started on question 5.